Welcome to Rosmaya Mohtar YouTube channel. Ready? Okay, the figure below shows a capacitor charged to 60 volt and a second capacitor is uncharged. Okay, uncharged. So this is initial. Initially, the first one charged to battery. Imagine we have a battery here 60 volt. So the charge on the capacitance here is 60 volt. Then we take out the battery. So fully charged here is 60 volt. And then the capacitance is 20 microfarad. This is the first capacitor. The second capacitor, it has no charge. Uncharged means no charge. The Q is 0. This is second capacitor. And the capacitance is 40 microfarad. Okay, now what happened? So these two capacitors are then connected together in parallel. So they join together like this. Okay, after the connection, find the charge and potential difference of each capacitor. Okay, so we're going to determine the charge and the potential difference. So the charge and the potential difference. So understand the question first, what it wants. Okay, it wants to find charge Q and potential difference V. Understand the question? Okay, now we solve. So this is the idea. You sketch the idea here. These two combine like this, parallel. Okay, first step. Uncharged. What is meant by uncharged? Uncharged means that the charge is 0. So when they are combined like this, okay, the total charge will be Q1 plus 0. When they are combined like this, the charge now can freely flow. Okay, freely flow in the circuit here. So the total of charge in the circuit will be Q1 plus 0. So you calculate lah. Q1 will be C1 V1, Q2 will be C2 V2. So because the charge 0 here, so we just calculate Q1. From here we use C1 and V1, 20 times 60. So this is the total charge in the circuit. Okay, it is equal to the total charge here. Because charge here 0, so total charge here equals to the total charge here is equals to the charge in this capacitor only. Because the charge from here start to flow to the second capacitor. Okay, understand me or not? So this is the first step. Find the total charge. So we get 1,200 microcoulomb. Okay, unit for charge is coulomb. So 1,200 microcoulomb. Okay, so the question asks for charge, charge on each capacitor. So the charge on capacitor 1 will become less because the charge start to flow. So it's no longer 1,200. It will become less because the charge start to flow out the circuit. Flow here. So the charge on capacitor 1 will change and the charge on capacitor 2 will increase from no charge here, from 0, then it will increase. But the total of charge remain the same. It is 1,200 microcoulomb. Okay, the total charge remain the same. But the total charge individually will be different because the charge now can flow out from them already. One receive, one become less. Okay, any problem or not? You can just write in the chat if got problem to understand me. Okay. So here, initially 1000, here 0, then total charge here 1200 microcoulomb. Okay, next we use the concept of parallel, parallel arrangement of capacitor. Okay, so because it is arranged in parallel, okay, the first concept, the voltage across them is the same. Okay, V. Okay, voltage across them, the capacitors will be the same. So we just write V. And the C1 plus C2, okay, capacitance, because they are arranged in parallel, we use the concepts of arrangement capacitors in parallel, where the C1 plus C2. So 20 microfarad plus 40 microfarad, we get 60 microfarad. So this is the total capacitance and the voltage across them, V, and the total charge, 1200 microcoulomb. So we can calculate the voltage across the capacitor here using Q total and C total. Okay, Q total equals to C total times the voltage across them. So we get voltage across them, okay, bring 60 to the left side. So we get 20 volt, 1200 microcoulomb divided by 60. Okay, we get 20 volt. Okay, 20 volt. So the micro here, microcoulomb, so we get 20 volt, the voltage across them is 20 volt. We can use micro. Okay, so next we are going, because the voltage across C1, 20, and the voltage across C2 also 20. Remember just now, it's the same. We use the parallel concept. So we can calculate the charge individually for each capacitor. So we use Q1 equals to C1V for this capacitor, where C1 is 20 microfarad and the voltage just now calculated is 20. So we substitute into here. So the charge in the capacitor 1 will be 400 microcoulomb. From 1200 microcoulomb, now it become less, 400 microcoulomb, because the charge can flow out already, can flow. So it become less to 400 microcoulomb until their voltage become the same. Then no more charge flow. The charge flow, it called current. Okay, the charge flow until it stop because of they have same voltage, which is 20 volt. Same voltage, 20 volt. So the second one will be Q2 equals to C2V. So C2 is given 40 microfarad. So substitute into here 40 microfarad. And the voltage across them is 20. So you get 800 microcoulomb. So the second charge on the capacitor is 800 microcoulomb. So check for the total, 800 plus 400, you still get total charge 1200 microcoulomb. Remember that the charge cannot run away anywhere. It still flow on the same circuit. So the total charge remain the same, 1200 microcoulomb. That's why here if we calculate the charge, 400 plus 800 is equals to 1200 microcoulomb with the same voltage across them because they are arranged in parallel. Okay, so this is for checking. If you don't get the same, so that's mean your calculation is wrong. Total 400 and 800, you get 1200. Total of charge, you get this. Okay, so that's all for this question.